Today we are diving into exciting, let's say, comparison between two anomaly detection frameworks. AnomaVision, which is I have implemented and optimized on top of AnoDot, and also Anomalib, which is a well-known and very structured repo. And I will explore the powerful of each one and when to use when well, let's see which, and I will try to show you a comparison between let's see with two data sets, MVTec and Visa, which is these data sets, and we will try to see which is I mean the speed, model size, the accuracy, and also the some other matrices. So maybe just as a review, the anomaly detection is like finding uh, and different let's see items that rare behavior, or let's see observations that which is let's see occur let's see only at a certain time, let's see. And we would like to compare these two AnomaVision and Anomalib. And you can see from this the overview I have the three times faster than frame per second. And this, by the way, these experiments run on my notebook. I have no GPU. It's only CPU, and the CPU it might be different, and might be of course it might be it will be different because I have already shown you that last time when I run the Anomalib, and the running time was 2 milliseconds for the Onyx and PyTorch models, and also for the Tensor runtime was zero point 0.5 millisecond, which is really fast and really optimized. It's let's say easy to integrate in any let's say device. And for the Anomalib, it's a deep learning library. They have implemented and integrated several and many algorithms. In my case, I have only PADM. I have only implemented and let's see, not implemented, just optimized the PADM. And this is, let's see, the dataset types of the dataset MVTec, and this is the Visa dataset. And this dataset is used for the comparison. And the thing we have two five key matrices. The image or you will see is the under let's see area under rock curve, which is measure the ability to distinguish between normal and abnormal images at the image level. And this one here, ability to precise localize anomalies within the image at pixel level. So this is the image, and this can tell you the image is let's see defected, and this one here, the pixel, for instance, this pixel is defected or not. And here this we can see frames per second, how many frame per second we can process in the inference during the inference time, not the training. And we can see that the model size. We can see what is the size of the model, and of course the PyTorch dictionary I have saved. It was 15 megabytes, and the and and the static, let's see, quantized integer 8 was 8 megabytes, which is super let's see I mean it's nothing, and it gives the same result as the PyTorch, the Python, the C++, and everything. Also, I have everything in my repo. I will show you in a minute. And the memory that we used in the during the training, and also it's measure the training and testing. So you can see here, this is the image under the curve, under the rock. So you can see this is some of the data sets, some of the classes, candle, cashew, and etc. This is run in a Visa dataset, and you can see this is our stuff. It's somehow, it's in this case it's somehow close to each other. I will not see this is my better, my algorithm is better than this or this. So, and you can see here it's close to each other. Now, the most interesting one is frames based on how many frame per second we can process. Oops. So this one you can see here we have can process 40 frame per second, and this one is just let's see 13 or 14. And it's the same for the memory. The memory is somehow closed. Sometimes let's see they are better in some data sets, and yeah. So now this is for the MVTec dataset, which is the same, exactly the same as I mean the matrices, which is image under the rock, frame per second, and you can see here it's 40, 45, and etc. Now this, let's see this just to have overview overall comparison. Let's see this is the AnomaVision on dataset Visa and MVTec, and this is the average value of all the classes on the dataset on the Visa, and also this one for the MVTec. So you can see this is the some classes are not working. Let's see. Well, what I have done in this the for the experiments is I have only taken the extracting the features from the first layer, and the number of features was 15 in both. It's comparable, apple to apple. And you can see this is frame per second is 44, and for the MVTech it's 42. And you can see here this is the bottleneck. I will say bottleneck. It's less than, you can process, let's say 10 or 12, let's say 12, 30, 40 frame per second, while here it's achieving this. And in the meanwhile the result is almost the same. So, but in our case, AnomaVision is better to process many frames per second. And as I said, this is done in this experiments done on CPU. And the key strength here, you can see the AnomaVision is 3 times faster. You can see it's 44, and here let's see 14. And so I will say that the location and the performance, it should be the same. I will see. You can see for example from here they are, for example, almost the same. But oops. And the key strength of the Anomalib, you have many algorithms. Let's see, large algorithm collection. You have not just only Padam, they have patch core, several. Let's see, at least 10, I think, or maybe more. And you can have great flexibilities. If one is not working, you can use the other one. The Sometimes they have better memory efficiency, which when you see, for example, no, this one is better. I mean, AnomaVision. And last but not least, so this is the conclusion. If you want to use, if you would like to use speed, let's see, is critical. You can use AnomaVision. If you have a limited storage, for example, if you are working with edge device like Raspberry Pi, Jetson devices, so you could use AnomaVision because the model size is 8 megabytes, and the localization and production environment, you can use it in the production. And not last time, in the previous course, MLOps, I have also used this anomaly vision in the Azure cloud. And for the anomaly, as we said again, it's algorithm flexibilities. You can use many, let's see, whatever you want. And what I just said, that if you would like to start with the, let's say to work in a production, you can use this. You don't need let's say to start to try and again try several methods and just choose the best one. So here's I'm giving you the best, let's see, algorithm that have been optimized. And yes, so let me just show how I have done the comparison here. So you can see this is the comparison. So this, for instance, if you run this, I have run this in a Anomalib. You can see it's in Anomalib device code. And after running this, let's see, we assume that we run the MVTec. So MVTec will try to produce for each class. Oops. For each class, you will have a folder, and if you go to a folder, let's see this battle, you will have Anomalib, the weight, and the model Onyx, and this is for the AnomaVision. It's the same. You have several models, and here you can see this is the 31 because I have 32 bits, which is in my PC. It's a CPU. It's fair enough. Let's see to use this because this one is also 32 bits. But if you use a GPU and floating point 16, this will be 15. Yeah, 15. And this will be 15. And the other one, let's see, static quantization will be 8. Now, after this, you will have, as I said, these two models for the H algorithm. And this is the comparison here. It's a JSON file. You can see the dataset, the class, the device, the timestamp. And here, this is the values for each, let's see, algorithm. For example, here AnomaVision, and this is for the Anomalib. Okay, and let's go. For instance, there's also some other. Let's see, which is summary. It's a collection. If you can see, you can open the JSON file itself. You can see the battle. This is a battle. This is a cable, and this results for each class. Let's see, and or you can use a CSV file, which give you, let's see, a better, let's see, visualization. So you can see this is a class. Let's see, format. Where is the format? Let's see, out of width. And you can see this is the AnomaVision image under the curve, Anomalib, AnomaVision, Anomalib, AnomaVision, Anomalib. And you can see this is the average value of each class, of all the classes. And you can see, for instance, the number of frame per second, which is this one here for Anomalib. Oops. And also for the, I will not save this. Also for the other dataset, which is Visa dataset. So you can see it's the same result. Also, it gives you a better visualization when you run it. So I haven't, let's see, saved that, unfortunately, but I have deleted the rest of the files, which sometimes it gives you like this, and also in the console printing. So I think that's it for today. Try to use it in a CPU, GPU, and edge devices. And if you detect any issue, please let me know. I will try to fix it and help you in such stuff. And yeah, thanks for watching, and see you next time.